All right, welcome to Properties of Logarithms. Notice it says we're going to solve logarithmic equations, which we've been doing, but we want to identify and apply these properties to help us solve these logarithmic equations. So to do so, we are probably going to be jumping around a little, but let's start here. All right, take a look at the left-hand side. I call these properties of powers. And you're going to say, well, gal, some of these are from algebra, algebra 1. When you have b, a number to any power, a number to the 0 power, you know it's going to be 1. So a property you've dealt with, seen before, not a problem. Then the next one, if you have b to a power n, it has to equal that same base and power combination. Okay? What that's really saying is maybe if it's in a different form, like b to the third equals b to the 6 over 2. 6 over 2 would reduce to third, so they would be equal. So if you have something to a power raised to a power, and then something to that same power, maybe just in a slightly different form, but it would equal that, obviously they have to be equal. Then you have your power of a power combination next. And the rule was here that you must multiply your exponents. If you have b to the m and you take it n more times, that means you have m times n possibilities, b to the mn. So multiply the exponents. One base, multiply the exponents. The next one is your division look or quotient. And if you have like bases and you are dividing, the rule is you actually subtract them. And last but not least, if you are multiplying and you have like bases, the rule is to add those exponents. So with that, we should be able to take those properties which we are familiar with and turn them into log properties. So if you have them on the left, those would be the power properties, or some of you would call them the exponent properties, because that's what we've been practicing, exponentiation to logarithmic form. And you should be able to take b to the 0, take it through the magic bubble, and get what it turns into in log form. So take a good look. We had, remember, b to the 0 power equals 1. So now we have the log of 1 in base b is 0. And your brain says, wait a minute, can I read that for meaning? I hope so. What's the exponent for the number 1 if I'm in base b? And the question is, it has to be 0. Because your brain should be saying b to the 0 power equals 1. And it's a true statement. Okay? Now I brought that over, so let's just erase. Okay? Next one. b to the n equals b to the n. Remember, if it's in a different form, it's only saying, oh yeah. Now I like to call this one the duh property, because it basically, if you read it for meaning, it is what it is. Ready? The exponent, and if I read this and underline as I go, what's the exponent, or say the exponent, for the number b to the n, and I'm already in exponent form, if I'm in base b, is what? So I said the exponent for the number b to the n in base b is what? You're saying, duh, it's the exponent that you have right there, and it's n. So that one, you know, we can deal with that way, but it's a little different than some of the others. Okay. Next one, power of a power. Through the little magic, and we get, let's see, I think it can fit right there nicely. When we had our power of power, we're still got a power, but notice, this is the one where you bring that power or that exponent out front as a multiplier. So see it here on the left? It's the exact same thing, but now it comes out as a multiplier on the right. So if you ever see a power in parentheses in log form, you could bring it out as a multiplier in front of the log form. That's going to be the shortcut. Remember, properties are just shortcuts, and we want to be able to use them to help simplify, and that's what you're going to see today. So next one we're looking at is division, the quotient property. Bring it through. Ooh, this is a little bigger one. Let's put it down here. If I have the log of a division in base B, I should be thinking of subtracting. You're saying, well, yeah, because I subtract the exponents when I divide. So notice, a single log as division is equal to two separate logs in subtraction. That's the key there. And last but not least, product of powers brings us over through the magic bubble. And again, this is a big one. So let's put it right there. And move it up a little. If we are multiplying as a single log, and that's the key to both of these. If I'm multiplying as a single log, here I was dividing as a single log, it will turn into two logs that are added. And we've said multiply, add the exponents. We say divide, subtract the exponents. There's where that falls in. Okay? So these 5 rules you need to keep. They don't necessarily have names, but they fall in with them. But we're going to use these properties as shortcuts to help simplify. So here we go. What is the log of the number, or sorry, read for meaning. There is something missing. You got your equal sign, obviously, that's not there. So, again, what's the exponent for the number 7 to the power of 26.8 if I'm in base 7? Good. I heard somebody say, duh, that's the one we've been doing. So 26.8 should be my answer. Now some of you say, well, how'd you get that? Well, if you read it again, what's the exponent for the number 7 to the 26.8 power if I'm in base 7? What's the exponent if I'm in base 7? You look at that and say, duh, it's right there staring at you. So now, Nova numbers. What's the exponent for the number m to the n if I'm in base m? Say it for meaning. Read it for meaning. Notice I'm not reading log or log. Next one. What's the exponent on the number 1? What's the exponent of the number 1 if I'm in base pi? And you say, wait a minute. So base pi. What's the exponent if I know the answer is 1? So what's the exponent for the number 1 if I'm in base pi? Well, pi. Pi to the first, pi to the second, pi to the third. What's the only one that's going to get you to 1? I'm hearing it. We have an answer of 0. Anything to the 0 power gives us a 1. And look at your property. It lines up right with it. It doesn't matter that you had a strange base number. Simplify again. The log of 1 in any base has to be the statement that base to what power equals 1. And there's only one exponent that does that, and that's 0. So the log of 1 in any base is 0. All right, we're going a little bigger. Notice we have a subtraction problem, and you have a property that has subtraction in it. This happens to be 2 logs that are being subtracted. So right away, brain has to say, wait, there was a log that said, write me as a single log. But if you write me as a single log and it's subtraction, then I have to turn it into, you got it, division. The base stays the same, but over here we have 3 over 48. Now start testing yourself. 3 over 48 is a fraction. Fraction can be reduced. So what does this turn into? Well, most people would say 3/48 turns into 1 over 16. So now read it for meaning. The exponent for the number 1/16, if I'm in base 4, is what? So we're looking for that number. And if you want to write it exponentially, you're thinking 4 to the what power equals 1 over 16. Answer? Okay, I heard some 2s. 2 wouldn't be right because we need a positive 16, and we have 1/16. But if we had a negative 2, we'd be good. So our final answer here has to be negative 2. Oh, this one, big. We got some subtraction, we got some multiplication, we got a fraction out front, so we're using a couple things. So let's do it in order, which means only 2 at a time, which is what you can do with normal numbers anyway. 2 at a time. Can't do all 3 at once. So if we look at just the subtraction, that's going to be real similar to what we just did. So 2 logs in subtraction turn into 1 log that's being divided. Okay? So log of 85 divided by 17. You can do that math. That log turns into 5. Okay? Plus, plus. Now do the second part. You know that, looking at your properties, the one that says I'm a multiplier out front should give me a power in the problem. So right away you're saying, well, wait a minute. That would be the log of 25 to the 1/2 power. Now, these are in base 10, obviously, because there's no subscript there. It's understood. But you do know that 25 to the 1/2 means something. You should recognize that as I'm the square root. So the square root of 25 is 5. Now we're looking at the log of 5 plus the log of 5. But wait a minute, that's addition. You can't just add them. We never said you know how to add logs, but we did give you a property that says if you see 2 logs being added, they turn into 1 log that's multiplied. And on this problem, that's all it would be to write me as a single log. You're not going to simplify that because 25 is not a perfect power of 10. 10 to the first, 10 to the second, 10 to the third, 25 is not. If it might say even round to the nearest tenth, then you could go to your calculator. But here, we leave it as a single log. One more of those. I have addition of like bases. The bases are 15, but again, you have to say, what's it say? If I have 2 logs that are being added, I turn into a single log of that same base, but what do? And the rule is you multiply. So 5 times 5 is 25, carry the 2. 4 times 5 is 20, and 2 is 22. So I'm looking at what is the exponent for the number 225 if I'm in base 15. The answer there, 2. We don't have to stop at a single log because that's a perfect combination. Another one, 2 times the log of 6 root 6 in base 6. The thing you want to look at here, it's got several things in that worry me, but let's deal with them one at a time. I see that 2 out front. And in one of your properties, you know a multiplier out front of a log means I'm an exponent. So let's write that, keeping everything else the same. So I got 6 root 6, and if I become an exponent, I am now squared. And with that, I should be able to square me. So if I square what's here, 6 times 6 is 36. Square root of 6 times square root of 6 would be the whole number 6. Keep working. You can do the multiplication. 6 times 6 is 36. Carry the 3. 3 times 6 is 18. Plus 3 is 21. So we get the log of 216 in base 6, and you check your multiplication tables real quickly and say, hey, is 216 a perfect combination of 6s? You can do 6 to the first, 6 to the second, 6 to the third, and you should have found out that, yes, 6 to the third is 216. Because that reads in words, the log of 216 in base 6, so what's the exponent for the number 216 in base 6? That puts a lot of you into this mode. 6 to the what power equals 216. Okay, so that would be your thinking or work step on that one. Right? That's what we're looking for. You can write some of that down. Some of it you can do in your head. But make sure your final answer, either way you cut it, should be that 3. All right, here we go. Now look at this one. We got a log x on one side. Let's use our multiplication again that we saw. Here's that multiplication. We know it's going to change. There's nothing we can do on the left, but we know that multiplier turns into a power. So let's quickly turn that into a power and think about what we have. We are in base 10 because you don't see any subscripts, so we're fine. What is 2 to the 4th, better known as? Okay, I'm hearing 16. And if you have 2 logs that are being added, which is what we have here, what does that turn into? Some of you would say a single log. A single log that what? Adding turns into multiplication. So 16 times 3 is 48. So now look at what we have. We got the log of x on the left has to equal the log of 48 on the right. If we say solve, that means you're finding x. Look at me. X equals 48. And it's just that simple. Not any undo me or anything like that. So you used how many steps here? How many lines to simplify using the properties? And then once you had it simplified, you were able to look at me and say what the unknown was. One more just like that, and we should be good. So here we go again. Take that multiplier out front, make it a power. Start thinking about what a power of 1/2 really means. Again, we're in base 10, so that should not be a problem. And I would just be bringing this left-hand side down, not doing anything with it. The 1/2 power 25, which means the square root of 25 is 5. So I'd get the log of 5 minus the log of 2. And so if we look at both of those and say, hey, what's the rule when I have two logs that are being subtracted? And most people would say, oh, that's one log that I basically just divide. So you don't have to divide that out and get a decimal or anything. You can just write y equals 5/2. If you do say 2.5, no big deal, but the question is why? That's just as good. It's lowest terms, finished. So these properties are going to take some time getting used to, and I just did a bunch of the practice in our cover the reading combination so that you should be familiar with that and look at them and use them as your guide.